Now we're still in the same part. You need to be careful. Yani, we did already, guys, here. You remember? Part 3, you wrote it. And then you did part 4. The title was Special Right Triangles. You wrote this one, right isosceles triangle. You wrote the two cases. Now I'm gonna pass to now semi-equilateral triangle. Okay? So what does it mean semi-equilateral triangle? First, it's a triangle that has an angle 30, 60, 90. Its name is semi-equilateral? It was an equilateral triangle like you see here. Okay? And then we cut it in half by doing a height. When I do a height, I will have here a 90 degree. Then I will take half of this triangle here and I will have my semi-equilateral. So this angle will be 30 because this one was 60, so it's also a bisector. So this is a semi-equilateral triangle. So it has 30, 60, 90. Okay. So all the time when I'm working with semi-equilateral triangle, you need to think about that. So let's see. If it was an equilateral triangle and all the sides were 6, so if this side was 6, 6, 6, it means the small size here is is 3 because it's a midpoint of it. So now I have here a right triangle with one side 6, one side 3. How do we find the third side? I'm gonna use what? Pythagoras, because I'm in a right triangle. So I'm gonna write the relation. I have a squared plus 3 squared equal to 6 squared because this is the hypotenuse. Then I'm gonna solve and find the length of the third side by using Pythagoras. And then the answer is 3 radical 3. Why I'm doing this? Because all the time, every time you have a semi-equilateral triangle, and you need to find the missing side, you need to go back to the original, how it was. It was like this, so this side is the double of this one. So all the time I have one side double of the other one. The hypotenuse is double of the smallest side. This is all the time. So we're gonna do now one case. This is a semi-equilateral triangle. How did you know that it's semi-equilateral, guys? Because here it's 60 and here is 90, so this angle is 30. Okay, so hypotenuse is given here. So case 1, I have 3 cases in the semi-equilateral triangle. I can give you the hypotenuse, you need to find those two. I can give you the smallest side between those two antibode. This is the smallest side, and the side between 60 and 90. You need to find those two. And I give you the longest side between those two. This one, in general, in a right triangle, the longest side is the hypotenuse. I will name this one hypotenuse. This one is the smallest, this one is the longest between those two. The first case, the hypotenuse is given. How I will find from this 8, those two sides. So all the time when you have it like this, how it was, you need to make it how it was. Yeah, I will take my pen and I want to see how it was. So my triangle was like this. It was like this before I cut it in half. So it was like this. Sorry. Okay. So, and now, yeah, it means this side was 8, and this side also was 8, and this side also was 8. So what represents AB now? It's 4. Why? Because it's half of the hypotenuse. This is the smallest one. So again, I'm going to repeat again from the beginning. So I had, the original figure was an equilateral triangle, and then we cut it in half. It was an equilateral triangle with side 8. It means this one was 8 and this one was 8. So if this one was 8, it means this one was 4. AB is 4. So now I can write, so ABD is semi-equilateral, so AB is equal to half of BD over 2, so AB is 4. Now I have two sides, 1, 8, 1, 4, so it's easy to find the third side by using what? Pythagoras. Using Pythagoras, AD squared plus AB squared equal to BD squared, and then I will replace by the given, and then I'll take 16 to the other side. Please, miss, you need to study it very well and review it. And if you have any question, you can ask me. Then I will have AD is 48. It means AD is radical 48. I will repeat again. It was given like this, ADB, and the hypotenuse was 8. It's a semi-equilateral triangle. If all the time you complete from the 30 angle, and it means it was like this, equilateral, and I cut it in half. It means that this side was 8, this side was 8, and here was 8. So AB is 4. So I have now 8 and 4. So I can find the third side. it's radical 48, and you can simplify it if you want. It's 4 radical 3. Now, okay, did you notice I have 1, 8, 1, 4, and this is 4 radical 3. So I have 4, 8 is double of 4, and here it's 4 radical 3. Let's see case 2, if I will give you this one, the smallest side, how we will solve. Now, case 2, the smallest side is given. Okay. Also, you completed how it was. See, I'll complete from the 30. So I'll take my pencil and I will see. So the semi-equilateral, the equilateral was like this, and then we cut it in half. What does it mean? It means that if this one is 3, so all the side was what? 6. 6, 6. So I know that my hypotenuse is what? 6. Again, and you notice the smallest is 3, the hypotenuse is 6. So the smallest side is all the time half of the hypotenuse. All the time my hypotenuse is double of the smallest side. Now I have two sides, 3 and 6. I can find the third one. Also using Pythagoras. ABD is semi-equilateral, BD is 2AD, so BD is 6, and then I will use Pythagoras. AD squared plus AB squared is equal to BD squared, and then I will replace by the giving values, will solve it normally, and then I will have AB squared is 27. It means AB is 3 radical 3. Did you notice? I have 3, double of 3, 6. Now here is 3 radical 3. In the preceding exercise, we had 4. 8, 4 radical 3. I'll go back to the preceding one to see it. So I had what? 4, 8, 4 radical 3. Now here, in the next exercise, I have 3, 6, 3 radical 3. So I have the smallest, because all the time half of the hypotenuse. The last case is the hardest one, when the longest one is given. Okay, the longest between those two is given. This is not easy. So here, if I look at this one, at this triangle here, the side between 90 and 30 is given, or the longest between those two, okay? I want to complete it to see how it was before. So the triangle was like this. Okay, but this is 4, okay? I know this one is, if this one is double of this one. DA is double of this, of AD. Here I cannot find the value of this. So how are we gonna do it? This one is the hardest one. It's very important. Be careful and watch how we're gonna do. So I don't know ABD, I don't know AD, so I cannot find those two. I just have this one, the height in the equilateral triangle, but it will not help me to find the others. What we're gonna do? I know that BD is double of AD. This one we know it. And I cut it in half, so this is half of this one. So I will say let AD be X, so it will be BD 2X, the double. And then I will replace that one. So using Pythagoras, also the same, AD squared plus AB squared equal to BD squared. نستبهمش all the time AD squared plus AB squared equal to B squared. I can change the letters. I can have A here, A, B, D like this. I can name it A, B, C. I can name it E, F, G. So just we need to write side squared plus side squared equal to hypotenuse squared. And then I'm gonna replace. X squared plus 16 is equal to 2x squared. It means 4x squared. How I passed here, so you're gonna ask me. Okay, I'll develop, I can read from the other side. I can read it like this. 2x squared, it means 4x squared is equal to x squared plus 16. I can do it like this. So 4x squared is equal x squared plus 16. I can take x squared to the other side from the hour like this. So 4x squared minus x squared equal to 16. Then I will continue now. 1 minute. So I will have 3x squared is equal to 16. X squared is equal to 16 over 3. Yani x is equal to radical 16 over 3. What is radical 16? 4. 4 over 3. And then I will rationalize it. 4 radical 3 over 3. Did you see the radical 3? I saw radical 3 many times. So what can I deduce about AD? AD is 4 radical 3 over 3. And BD is times 2. So 2 times 4. So 8 radical 3 over 3. So, did you notice something in the semi-equilateral triangle? All the time I have hypotenuse double of the smallest one. The smallest one, it means it's a side between 90 and 60. And all the time, the high, there is something linked to radical 3. You can do it as I did. Those are the three cases. There is no more cases. And if you saw the rule, I will show it to you, but I don't want you to memorize it. I want you to know how to do it all the time. Complete the triangle, go back. It was what? It was an equilateral. Yani which side was the double? Which one was the midpoint, the half? And then you do Pythagoras and you find the remaining sides. Now let's go here. This is the rule, but as I told you, I don't want to memorize it. If you notice that all the time I have here the smallest side is x, the hypotenuse is double to x, and the height, the third one, the length between 90 and 30 is x radical 3. Okay, so and all the time find the shortest leg first. So this is x, the smallest one, the hypotenuse to x, and here is x radical 3. So in a 30, 60, 90 right triangle, the hypotenuse is double as long as the shortest leg, and the longer leg is radical 3 times as long as the shorter leg. But as I told you, I don't want to memorize the rule. You can do it as I did before. So if you have any question, you can ask